Hey there, physics explorers. Quick question. Have you ever noticed that no matter how goofy a face you make in the mirror never lies? It always shows the same geometry, no surprises. That's because light isn't just bouncing randomly, it follows strict rules called the laws of reflection. And here's the exciting part, these laws don't just apply to your bathroom mirror, they work for shiny floors, calm lakes, and even curved car side mirrors. They are universal, tried and tested, and they are the reason we can design telescopes, periscopes, and even selfie cameras. Let's dive into these magical but simple laws. Alright, first law, my favorite because it's simple and elegant. The angle of incidence equals the angle of reflection. Let me break that down. The angle of incidence, which we call I, is the angle between the incident ray and the normal. The angle of reflection, which we call R, is the angle between the reflected ray and the normal. So, the equation is I equals R, that's it. If a ray comes in at 30 degrees, it goes out at 30 degrees. If it comes in at 57 degrees, it leaves at 57 degrees. Symmetry at its finest. It's like a well-disciplined dance move, whatever step the incident ray takes. The reflected ray copies it perfectly on the other side of the normal. Now the second law, this one keeps everything tidy. It says the incident ray, the reflected ray, and the normal all lie in the same plane. Think of it like playing carom. If you strike the striker on the board, it never jumps off into the air, everything stays in that flat surface, the plane of the board. Similarly, in reflection, nothing pops out into 3D randomly, all action happens in one flat plane. This law ensures that our reflection diagrams can be drawn on a piece of paper instead of requiring holograms floating in space. Practical, isn't it? Now let's look at a special case. What happens if the light ray comes in exactly perpendicular to the mirror? That means the angle of incidence I equals 0 degrees. And by law 1, angle of reflection R also equals 0 degrees, which means the ray goes back exactly along the same path. It retraces itself. So if you shine a torch straight at a mirror, the reflected light will come back right into your eyes. It's like saying, no deviation today, thank you very much. That's what's happening in normal incidence. Okay, let's flex our math muscles a bit with an example. Suppose a light ray strikes a mirror such that the angle of incidence is 55 degrees. Step 1. By the first law of reflection, the angle of reflection is equal to the angle of incidence. So R equals 55 degrees. Step 2. What's the angle between the incident ray and the reflected ray? That's simply I plus R. So, 55 plus 55, which equals 110 degrees. So here's the final picture. The ray comes in at 55 degrees with the normal, bounces out at 55 degrees on the other side, and the total spread between the incoming and outgoing rays is 110 degrees. That's the beauty of reflection, predictable, precise, and exam-friendly. Let's wrap this up neatly. The laws of reflection are twofold. First, the angle of incidence equals the angle of reflection. Second, the incident ray, reflected ray, and the normal all lie in the same plane. These laws are universal, whether you're dealing with plain mirrors, shiny steel, or curved telescope mirrors. And in special cases like normal incidence, the ray simply retraces its path. So next time you see yourself in a mirror or watch sunlight bouncing off a lake, remember, those rays are quietly obeying these two simple but powerful laws. And that, my friends, is the discipline of light. I hope this clears up the mystery of reflection. Until next time, keep your minds bright and your questions sharper than a mirror's reflection.